Okay, so as I was saying, the net force in the x direction is 0, which means that this friction force to the right and this normal force between the building and the ladder to the left have to be the same size. Now, the net force in the y direction is also 0, which means that this normal force applied to the bottom of the ladder by the ground has to be the same size as the weight of the ladder plus the weight of the painter. And since we know the masses of the ladder and the painter, we can figure out this normal force right now. The 20 kilogram ladder has a weight of 196 newtons. The 80 kilogram painter has a weight of 784 newtons. So that's a total weight of 980 newtons. That's N1. All right, now we can also, because the ladder is not rotating, the net torque is also 0. Now, you can pick your center of rotation to be anywhere on the ladder. What I recommend is to always pick your center of rotation to be here. And that's because there are two forces acting on the ladder at that point. Now, if you make this your center of rotation, both of these forces have a distance of 0 from the center of rotation, which means they both apply 0 torque. So when you go forward, you only have 3 forces that could create torque. These two forces can't create torque at this point. So my net torque is 0. So I'm going to look at these 3 forces and the torques that they create. Now, remembering that counterclockwise creates a positive torque, N2 will produce a positive torque. The weight of the painter and the weight of the ladder will produce a negative torque because they would make a clockwise rotation. So, N2 is 4 meters from the bottom of the ladder because the ladder is 4 meters long. So I'm going to do R times F, we don't know the size of N2, times the sine of the angle between them. If this is 70 degrees between the ladder and the ground, this is 70 degrees between the top of the ladder and N2. Now, for the weight of the painter is also 4 meters away from the bottom of the ladder, but this would produce a negative torque. So for the painter's torque, I'm going to do minus R times F times the sine of the angle. If this is 70, this is a 20 degree angle here. And then for the torque created by the weight of the ladder, minus the distance from the bottom of the ladder to the center of gravity times the weight of the ladder times the sine of 20. That angle is also 20 degrees. So now you have an equation here with only one unknown, N2. You do some algebra and you get N2 equals 321 newtons. Now, the problem asked us to figure out the minimum coefficient of static friction here. Well, the coefficient of static friction is going to equal F over N1. Well, we already figured out that F is the same size as N2. So down here, I figured out the coefficient of static friction by taking N2, which is the same size as the friction force, and dividing by N1, and I got 0.33 for the coefficient of static friction. Was I kidding or was I not kidding? These are fun problems. So have fun with these, and I hope that it all goes well for you.